Hello everyone and welcome back to Dubious Engineering. Yes indeed, it's the 3D printed laptop project. It never really got finished off properly, so I thought to myself, wouldn't it be cool to actually just get one of these projects finished up, sort of proper, so that it's useful to me. So in order to fix it, we need to pull all of the batteries out of it because I didn't fit a BMS, I didn't fit a battery management system into this laptop, and I let the smoke out of the machine at one point. In fact, I believe I'm going to show you that about now. I tell you what, that was a moment. Somebody mentioned in the comments in a video that I showed just a little while ago that he said he was quite impressed with the way, you know, I just sort of let the smoke out and then waved it away and carried on. Yeah, it did sort of shock me that I can't remember what I did exactly there. I think I shorted, well, clearly I must have shorted something, and obviously I hadn't put any fuses in there or anything like that. Anyway, as you can see here, the batteries are all cream crackered. None of them have got any output voltage apart from that one right there. So there is one working 18650. Everything else is completely Donald Ducked. So we'll get rid of those. And have to clearly dispose of those batteries responsibly. And what we are going to have to do is actually put some kind of DC barrel jack port on the side of this so we can plug in a charger. And one thing I can tell you is, having now built this, and because I'm doing a voiceover at the moment, as you might guess, but having built this unit, the batteries actually last for a really long time. I can get about 6 hours out of these batteries on this tiny little Raspberry Pi 3 computer with an LCD display. It's got a couple of funnies going on as well, stuff to do with Wi-Fi, but that's nothing to do with Windows patches if you're up to speed on that kind of business. But anyway, moving swiftly on, I have here a fantastic meter, and I absolutely adore this meter. In fact, I bought one of them for a previous project, and I've ended up buying a few of them. I think they're about 4 or 5 quid. So you can use it as a voltmeter, a little DVM, and at the same time it will give you an idea of how much capacity there is left in the battery. And that's always very useful, especially when the Raspberry Pi doesn't have any analog inputs on it. It's only all of those pins on the pin header that the Raspberry Pi has. They're all digital I/O. Unless you were to connect a little A to D chip, you wouldn't actually be able to figure out what voltage your batteries are at, which is a bit silly really, considering it's a little tiny portable computer. I'm sure it wouldn't have cost much to add a little A to D there. Anyway, as you can see, I connected this up to a 12 volt supply with some crocodile clips there, and it works. And I found myself some nice new batteries, all of which are hitting at about 20 amps short circuit current, and all of which are nicely on target with their voltage. So I'm going to go ahead and make up some individual battery packs, and once those individual battery packs are all made up, I'm then going to connect them all to a BMS, to a battery management circuit. Boom, look at that. As if by magic, I soldered it all up in a few seconds. I do love this camera trickery. So there it is, that's the new power supply for the 3D printed laptop. And that's a 12 volt BMS. And somebody was asking me the other day in the comments section, please can you give me the number for that BMS? Maybe if you pause the video for a few seconds there, you might actually get the number off the BMS. But ultimately, on eBay, if you type in a 12 volt 3 cell BMS, there's loads of them out there, and they cost sort of £2 or £3 a go. There we go, new batteries in. Wires are a bit messy, and I do tidy that up in a little while, but ultimately I just wanted to sort of make sure it all fitted in place and everything sort of worked. It's a bit like sort of prototyping things before actually committing. Next part of the process, because this is a little tiny Raspberry Pi, it's got a tiny little headphone port on it, and it doesn't really drive a lot of power into any speakers. It's good if you're just going to plug your headphones in, but ultimately I wanted a decent speaker on it. Well, not a decent speaker, I wanted a speaker on here. I didn't want to just use it with headphones all the time. So I found myself a little tiny amplifier that had a large speaker in it, and I also found myself, from an old reclaimed laptop, an old reclaimed laptop speaker. Just a case of combining the two of those things and wiring them into the 5-volt drive output of the little power supply there. And as you can see, the LED comes on, which hopefully means that that amplifier is up and running. And I soldered it directly, as you might notice, to the jack, to the audio jack on the Raspberry Pi there. Right, time to get the glue gun out, and let's go ahead and glue all of these batteries in place and make sure they're good and secure in their little container. So oodles of glue go in here. The batteries will then get laid down flat. And I've put a little bit of tape over the BMS PCB just to stop the potential for anything shorting on that. There was part of me that was thinking of sort of heat shrinking all of that. But to be honest, I quite like the idea of being able to lift up the keyboard and show people what this little laptop has inside of it. So there is a Raspberry Pi 4 with 2 gigs of RAM on board, and the power supply plus 5 volts and 0 volts are connected directly to the IDE header. There's a 32 gigabyte SD card fitted into the SD card slot. Left and right channel of the audio jack have been connected together to create a mono drive output for the amplifier. The amplifier is then driving a single mono speaker. On the side of it, we've got a DC barrel jack where you connect 12.6 volts. That 12.6 volts from the BMS is then put into a 5-volt buck converter, which creates the 5 volts for the Raspberry Pi at 2 amps. There's a little switch on the front of it to turn everything on and off. And then there is the actual BMS itself, which we were talking about earlier, underneath a little bit of plastic tape there, connected to all of those batteries. Yeah, it looks a bit messy in here. I wanted to be able to take the keyboard off the top of this and show people how this is made and talk about what's inside of it. Anyway, let's have a look and see how useful this is. Here it is then, the Raspberry Pi laptop. Let's just turn it on straight away. So we'll turn the switch on the bottom, and what that does is it connects this battery management PCB here and all of the batteries to everything else, and immediately it connects it to the meter, and hopefully you should be able to see here on the meter that it says it's currently 12.1 volts. And you have an option to be able to turn off the meter, change that to the percentage left of battery power remaining. Loving this meter. The meter does exactly what it says on the tin. It's currently showing 12.1 volts and the battery is almost fully charged. And hopefully you can see the screen has lit up there. The Raspberry Pi booted in half a heartbeat. The speaker works. Everything sort of does what it says on the tin. This is a Raspberry Pi, I think I said it was a Raspberry Pi 4 2 gig, it's not. Raspberry Pi B3 Plus there, and the keyboard here which just sits perfectly on top of that hole, and as you can see there's hardly any movement in that at all. It doesn't really slide around. So if we turn the keyboard on, little tiny switch here, little power light comes on, and then we should be able to, there we go, and now we can see a mouse moving around on the screen. So why don't we go ahead and shut the lights down. Hey Google, turn the socket off.
Turning off the socket.
And then let's zoom, whoops, and then let's zoom you in. Hopefully you can see what is going on my screen. This, by the way, is a map of Return to Zork.
So it's quite responsive, as you can see. It's, you know, it sort of it hops around quite quickly. Everything sort of looks quite good. So if we go to games, I downloaded a Z5 emulator, is it? Or interpreter, perhaps. And this is called Gargoyle. And what this does is it gives you the ability to be able to play text adventure games. So here I've got a folder with text adventures, and this one is Zork. So if we can go ahead and open Zork, I managed to find the configuration file for this bit of software, so you could adjust the size of the fonts and that kind of thing. And now, of course, I've turned the lights off. I can't see the keyboard anymore. I need a backlit keyboard. That's the next mission, clearly. So this is Return to Zork, and yes, I beg your pardon. Crikey, I can't see what I'm doing. Blah, 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 blah. So I can play some text adventure games, which is great fun. There's also some other games on here which are quite fun to play around. Alien Blaster. Got its uses, or certainly it's a good bit of fun to have a tinker around with. So really it's just, you know, it's Raspberry, and what more can I say? It's running Raspberry, and let's fire up the internet. And you'll see here the mouse is just sort of showing the egg timer. So give it a few seconds. Here's a new tab, there's Google. And yeah, let's Google up and let's see what happens when we type dubious engineering. Look at that. There we go. Straight on to YouTube. Fun engineering projects. Dubious Home, Facebook. Dubious Engineering on Social Blade. Dubious Engineering on Instagram, on Patreon. Little bit of lag, a little bit of delay. Right, let's go full screen. All right. Oh, there we go.
Coffee table. I'm on holiday, she's at work, and I'm going to modify the coffee table, turn it into a games machine.
Anyway, there we go. Look at the screen. Right. Shush. Look at the screen. Yeah, everything looks pretty good, doesn't it? You know, it's really quite pleasant to look at. So, anyway, there we have it, the wonderful Raspberry Pi laptop. Ladies and gents, the 3D printed Raspberry Pi laptop. You know, it's not perfect by any stretch of the imagination, but it fits in that kind of a form factor, and it works. It's got a lovely little screen on it. It's a shame the screen isn't a little bit thinner. But, you know, it was as good as I could do with the technology that I had at the time. And bearing in mind I started this project, I would say a year ago. Anyway, the display is magnificent. The battery lasts about 6 or 7 hours. So clearly the Pi 3 and also this particular LCD display don't use an awful lot of power. I'm quite impressed with the battery life. And the fact is, it's functional. You can watch YouTube videos, you can get on the internet and have a look around, browse the web, as they say. You know, it does what it says on the tin. It's a Pi and it's Raspbian. When the Raspberry Pi first came out, I struggled with it. I didn't think it was very good, just because it was a Linux X type, X11 type environment. I was struggling a little bit to sort of, you know, get used to it. There wasn't, getting software for it wasn't very easy. Sadly, it wasn't as easy as using something like Windows. But as time has gone on, Raspbian OS have really stepped up their game, and actually this is now almost flawless. There are a few things, you know, bits of JavaScript that still don't quite work. So if you wanted to play the BBC Java emulator, and unfortunately that doesn't work. But you know, generally speaking, it's there for 90% of what you need it to do. I'm going camping soon, and I'll take this along with me, and I'll put this through its paces on our camping trip, and that'll be quite good fun. See how we get on with it. See what we can use it for. Anyway, here it is. The Raspberry Pi laptop. I love it. Ladies and gentlemen, thanks ever so much for watching. Give us a big thumbs up, subscribe if you haven't already, and we'll see you in the next video. Take care, people. Bye for now.